Okay, so today we're diving into one of the wildest, most ambitious claims I've seen in a long, long time. We're talking about a single equation that someone claims can solve all of math's greatest mysteries. Yeah, you heard that right. It's an idea so big it could literally rewrite our understanding of, well, everything. I mean, just look at that question. It sounds like something straight out of a sci-fi movie, doesn't it? But this isn't fiction. A researcher has actually formally made this exact claim. They've put forward a proposal so huge it aims to change how we see reality itself. And the timing here? Oh, the timing was absolutely deliberate. It was chosen for its deep symbolic meaning. It's like they were trying to draw a line in the sand, marking the end of one entire era of science and maybe kicking off the next one. So let's just picture this for a second. It's December 31st, 2025. This is the very last day of the 100-year anniversary of quantum mechanics, the theory that has defined physics for a century. And on that day, a manuscript lands at the Princeton Annals of Mathematics claiming to have solved all 7 of the legendary Millennium Prize problems. I mean, talk about an audacious way to close out a century. Now, to really get how massive this claim is, you got to understand the challenge itself. We're not talking about your average tricky math homework. These are the 7 great problems, the absolute Mount Everest of mathematics and physics. So, back in the year 2000, the Clay Mathematics Institute put a $1 million bounty on each of these 7 problems. That's a $7 million prize pool. But let's be real, the money is almost a footnote. The real prize is figuring out the answers these problems are hiding. These aren't just random brain teasers, right? They were specifically chosen because they are 7 of the most fundamental, deep, and difficult questions we have about how logic, space, and the universe actually work. They were meant to be the guiding stars for math research for the entire 21st century. Solving even just one of these is a career-defining, history-making event. And what's so cool is that we can boil these giant problems down to some pretty intuitive questions. Like P versus NP is basically asking if finding a solution to a problem is always way harder than just checking if a solution is correct. The Riemann hypothesis asks if there's a hidden pattern in prime numbers. For over 20 years, only one of these has been cracked, the Poincare conjecture, which was solved by the legendary Grigori Perelman. This new paper claims to solve all 6 of the others. All of them. So what is this supposed key, right? How could one thing possibly unlock all 6 remaining problems at once? Well, the researcher, Lane Cunningham, proposes something called the master equation. The core idea behind it is, honestly, it's radical. It argues that quantum mechanics, the bedrock of physics for 100 years, it's not the real deal. It's just a projection, a shadow cast by something much, much deeper. And that something deeper, pure geometry. The idea is that all the weirdness of the quantum world, the probabilities, the uncertainty, isn't fundamental. It's just the messy, distorted shadow cast by a perfect, simple, underlying geometric reality. If that's true, wow, it would finally unite the quantum world and our everyday classical world under one elegant idea. And this is the proposed key. Now, don't worry about all the symbols. The core idea is that this equation describes how any system, anything at all, settles into its most likely state, its lowest energy, or E. The claim is that this one single principle of probability governs everything, from how water flows to how prime numbers are scattered. It suggests that if you can figure out the energy of any mathematical problem, this equation can reveal its fundamental structure and boom, unlock the solution. So this is really the mic drop moment of the whole thing. The paper argues that these 7 problems are not 7 separate puzzles. They're actually all just different reflections, different faces of the exact same underlying physical principle. So you don't solve the problems one by one. You solve the core principle and you get all the solutions as a result. It's a truly grand, unified idea. But, and this is a huge but, having a beautiful, elegant claim is not nearly enough, not in mathematics. Any new idea has to survive a trial by fire. It has to face the gauntlet of proof. And this quote just says it all, doesn't it? You don't get to just declare a problem is solved. Your proof has to be attacked, picked apart, and stress-tested from every single angle by the smartest people on the planet. And only if it survives all of that is it accepted as truth. Let's just get some real perspective here for a moment. On one side, we have this new manuscript submitted by one person. On the other side, we have Grigori Perelman. He didn't even submit his proof to a journal at first. He just dropped it online. And it then took three full years for the global math community to go through it and finally agree that yes, it was correct. In fact, the official path is no joke. The Clay Institute has it all laid out. Getting published in a peer-reviewed journal, that's just step 2. After that, the proof has to survive 2 more years of public scrutiny. So submitting the paper, that's literally just knocking on the door. You haven't even gotten inside yet. This quote from Perlman, who famously turned down both the $1 million and the Fields Medal, the Nobel Prize of Math, it says everything you need to know about the culture. For a true mathematician, the prize isn't the money. It's not the fame. The ultimate reward is knowing the proof is correct. The truth itself is the only prize that really matters. Okay, so with all that healthy skepticism laid out, let's just let ourselves wonder for a second. What are the stakes here? What if, against all the odds, this thing actually survives the gauntlet? What if it's true? Well, if it's true, the implications they're staggering. It wouldn't just be a new chapter in physics, it would be a whole new book. We'd have a single framework connecting everything from the shape of the cosmos down to the security of the internet, all flowing from one geometric idea. It would be answers to questions that have stumped the greatest minds for a century. So, what's it going to be? A breakthrough that redefines our entire century, or just a fascinating, ambitious footnote in the history books? The honest answer is we don't know. And that's the beauty of it, isn't it? The claim is out there, the gauntlet has been thrown down, and now the rigorous, relentless, and beautiful process of science gets to decide.